Our earthly home and its planetary system are situated in that barred spiral galaxy we call the Milky Way. This cosmic collection of thousands and thousands of stars, celestial bodies, gas nebulae, and dust clouds has fascinated astronomers for millennia, and the groundbreaking discoveries that are regularly recorded in the Milky Way prove that we are still far from having unraveled all the great mysteries of our home galaxy. We get an authentic impression of how enormous our galactic home truly is when we allow our gaze to wander to the firmament during starry nights. The next movie will teach you about some of the remarkable natural objects and structures that scientists have discovered in the barred spiral galaxy. If you're excited about the amazing sights and discoveries of our universe, don't forget to subscribe to our channel so you can regularly learn more about these exciting subjects. You can also give us a thumbs up if you enjoy our videos. Now, let's look at the strange phenomena that famous scientists have recently noticed in the Milky Way. Experts have documented roughly 1,000 of these amazing phenomena, but because the emissions only last a few milliseconds at a time, it is extremely difficult to study the radio flashes in detail. In fact, they have only been able to trace a very small portion of the phenomena back to their extraterrestrial origins. Fast radio bursts are lightning-fast but incredibly intense. Bursts of radio waves that typically originate in distant galaxies. Sources in the galaxy, unbelievable yet accurate. Because of the inherent challenges in studying these radio wave emissions, scientists are still unable to determine with certainty how the short-lived phenomena are produced, even though radial flashes can have a lifespan of only 1,000th of a second at times, but during these brief moments, they produce as much energy as the sun. In the course of their research, experts were able to not only trace the radio bursts back to their home galaxies, but also produce high-resolution images of those galactic areas, specifically identifying the regions surrounding the spiral arms of the corresponding host. The 5 fast radio bursts that were recently probed with the aid of the Hubble Space Telescope may now help solve this mystery. These kinds of galaxy discoveries aid scientists in solving the cosmic riddle. The photos allow for the investigation of the mass distribution and the calculation of the star formation rate, among other crucial findings regarding the galaxy's characteristics. Scientists will be able to examine if galactic activities could also result in the emission of rapid radio bursts after they identify which cosmic spectacles are occurring in the locations of origin. Among the 5 fast radio bursts that were recently observed by the Hubble Space Telescope and traced back to their origin, there was for the first time a radio burst that was not a repeater. There are 2 classes of fast radio bursts: regular, repeating radio bursts, known as repeaters, and phenomena that only occur once, making them incomparably more difficult to investigate than their counterparts. According to recent research, there are numerous theories in the scientific community that try to definitively explain the genesis of fast radio bursts, but fast formations are still mostly unknown. The idea that the formations come from magnetars has attracted more scientific attention than ever before. Magnetars are a type of neutron star that is distinguished by its unmatched magnetic fields. These amazing celestial bodies are created when massive stars explode as supernovas. The small structures typically have an intrinsic diameter of just over 12 miles. Magnetars are known to release powerful emission bursts called flares, which are so intense that, under the right circumstances, we can even replicate them on Earth. In fact, Experts are currently engaged in a heated discussion about the theory that the fast radio bursts are produced during these flares, although it will be years before the question of the true galactic source of these amazing phenomena can be fully answered. This hypothesis suggests that the extremely strong magnetic processes on the magnetars could cause enormous radio wave flashes to be emitted. In fact, researchers have only been aware of the existence of these cosmic spectacles for 20 years. The Milky Way's first rapid radio burst, the idea that rapid radio bursts originate in magnetars, is validated. In the meantime, astronomers registered in our Milky Way within the last year discovered the first fast radio burst ever detected in our home galaxy. The magnetar, known as SGR 1935 plus 2154, was the source of the emission, and although the closest detected radio wave pulse had occurred 490 million light-years away from our home planet, the corresponding magnetar in the Milky Way is only 32,600 light-years away from our Earth. SGR 1935 plus 2154 is one of about 30 known magnetars in our home barred spiral galaxy. Researchers at the Stare 2 radio telescope in California and Utah were fortunate enough to capture the full magnitude of the fast radio burst, and they claim that it was by far the brightest ever studied scientifically. Scientists are currently employing two different approaches to address this issue. On the one hand, it's possible that the process is triggered by a phenomenon inside the magnetar, making it possible that so-called star earthquakes occur in the celestial bodies, during which parts of the surface are torn open and energy flows outward. On the other hand, the measured intensity of the burst was 1,000 times weaker than those fast radio bursts produced in other galaxies. Even if the theory that the magnetars are the origin of these spectacles proves to be correct, the question of which galactic interactions ultimately cause the fast radio bursts remains open. Theoretically, radio waves could be emitted in the strongly magnetic area surrounding the magnetar due to an as-yet unidentified event. Peculiar structure in the Milky Way's core. There are other topics that keep researchers in the Milky Way interested besides the subject of where the quick radio bursts originate. Spellbound, a while back, a number of odd formations were found in our own galaxy that the experts were totally unaware of until a few years ago. At that time, experts came to the conclusion that the Milky Way's center is adorned by a massive black hole, which was named Sagittarius. Among the most mysterious objects orbiting the supermassive black hole are 6 celestial bodies that at first could not be categorized in a standard scientific framework. A star has a lasting impact on the celestial bodies and its near neighborhood. About 15 years ago, experts discovered the first object of this type, the structure known as G1, which is followed in 2011 by the discovery of G2, a massive gas cloud, whose mass appears to be 3 times greater than that of our home planet. Although the structures appear to be classical gas formations, they actually behave like conventional stars, opening up a series of entirely new celestial bodies that are now referred to as G-class, the enigma of G objects. G2 was directly en route to Sagittarius. Large portions of the gas cloud drifted to within roughly 16 billion miles of the supermassive black hole 2 years after the star was initially discovered. As a result of the tremendous forces acting on G2, the object was torn apart to this day. The area surrounding Sagittarius has yielded the discovery of 6 G objects. One particularly perplexing aspect of a star is that, although they exhibit the dynamic properties of stars, the structures expand like typical gas and dust clouds as soon as they get close to the black hole. Stranger still, the objects appear to retain all of their own matter during their frequent flybys around stars. In particular, the various G objects require 1701,600 years to fully orbit the Milky Way's central black hole, and some experts believe that these enigmatic celestial bodies may be merged stars. The foundation of this argument is the observation that G2 lost its gas shell as it approached Sagittarius. When we consider the size of G1 and G2, each of which occupy an area roughly equal to that of our solar system, it becomes evident how imposing the spectacles of the universe are. A star, but not its dense dust mantle, suggests that the debris of the merged stars may have been too stable to be sucked up by the giant black hole. How do you feel about the Milky Way's enigmatic architecture and phenomena? We appreciate you viewing, and we hope to see you again soon. Please share your views, opinions, and suggestions in the comments section. You can also watch the fascinating videos we've included in the credits.